Hello, guys. My name is Nandivardhan Reddy from third year ITA section. 20951A1248 is my roll number. Today's subject is software testing management, and we are going to learn about asserting accuracy, pretend transformation for unit tests. Okay, we'll go into the topic. These are the topics. Introduction. What are the transformers? How to pretend transformers generate asset state benefits of using pretend transformation for unit testing, limitations and challenges, and the conclusion. These are the topics. We'll go to the introduction. Introduction. In the world of software development, unit testing is a crucial part of ensuring the quality and functionality of code. One key aspect of unit testing is writing accurate asset statements that verify the expected behavior of functions or methods. However, writing these assert statements can be time consuming and error prone, especially for complex code bases. That's where pretend transformers come in by leveraging the power of natural language processing. This model can generate accurate assert statements automatically. What are pretend transformers? Okay. Pretend transformers are a type of machine learning model that has been trained on a large amount of text data, such as books, articles, and websites. These modules use a technique called learning to adapt their knowledge to new tasks, such as generating asset statements for unit testing. One popular pretend transformation is GPT-3, which has been shown to be highly effective at generating natural language testing. By fine-tuning this model on a datasets of code and corresponding asset statements, we can create a powerful tool for automating unit testing generation. How to pretend transformers generate asset statements. To generate asset statements, we first need to provide the model with some context specifically the functions or methods that we want to test. We can do this by feeding the code into the model and asking it to predict the corresponding asset statements. The model then uses its knowledge for natural language to generate a statement that accurately reflects the expected behavior of function or methods. These statements can be further refined using techniques such as beam search or sampling, which allows us to explore different possible outputs and select the best one. Benefits of using pretend transformation for unit testing. Using pretend transformation for unit testing has been several benefits. First and foremost, it saves time and efforts by automating the process of writing asset statements. This means developers can focus on their aspects of coding quality and functionality. Additionally, using a pretend model ensures that the generated asset statements are accurate and reliable, reducing the, reducing the risk of bugs and errors in the code base. Finally, by leveraging natural language processing, these models can also help improve the reliability and maintainability of unit tests. The limitations and challenges. While pretending transformers offers many advantages for unit testing, there are also some limitations and challenges to consider. One major issue is the potential for overfitting. If the model is too closely tailored to specific code base, it may not generalize well to other projects. Another challenge is the need for high quality training data without robust data set of code and asset statements, the model may not be able to learn effectively. Finally, there is always the risk for errors or inaccuracies in the generator asset statement, which must be carefully reviewed and validated by humans. Okay, these limitations and all these things are the things which we will learn. Then we'll discuss deeply about this. Generating accurate asset statements for unit test cases is important task in software development, as it helps to ensure that code is functioning correctly and meeting its in, intended requirements. Written transformations such as BRET and GPT-3 can be used to generate asset statements automatically. Based on input and output data, here are some key considerations when using written transformation for task. First, training data, then language understanding, then limitations, then integration, benefits. All we will discuss this. But first, training data. To generate accurate asset statements, written transformers require large data sets of labeled input-output pairs that represent correct behavior. The training data can be generated manually or automatically using techniques such as fuzzing. By using fuzzing, we can automatically using the techniques such as fuzzing. Language understanding. Retained transformers are designed to understand natural language, which can make them well suited for generating asset statements that reflect the accurately reflects the intended functionality of the code. Okay, the will see limitations. Written transformers may struggle with generating accurate asset statements for complex or highly specialized code and may require additional training or fine tuning to improve their accuracy. Integration. Pretend transformers can be integrated with existing unit testing frameworks such as JUnit or PyTest to automate the generation of asset statements and streamline the testing process. Benefits. The benefits of this pretend transformations is the use of pretend transformation for asset statements automatically based on input and output data. Here are some key considerations where using pretend information. The use of pretend information for asset statements generation can save time and improve accuracy of unit testing, well, while also reducing the risk for human errors. Overall, overall these things overall receive summary. Overall, the use of written transformation for asset statements generations represents an existing new area of research in software testing, with the potential to greatly improve the efficiency and accuracy of unit testing in variety contexts. This is the summary. Okay. Then we'll go to the conclusion. Here is the conclusion comes. In conclusion, retained transformers offer a promising approach to automating the process of writing accurate asset statements for unit tests by leveraging the power of natural language processing (NLP). These models can save time and efforts while improving the reliability and readability of code. However, it is important to be aware of the limitations and challenges associated with this approach and to carefully validate the results to ensure that they meet the necessary standards for accuracy. Okay, This this some benefits are the use of written transformations for assert statements. Generation can save time and improve the accuracy of unit testing while also reducing the risk of human errors. By this transformation, human risk of human errors also decreases, and accuracy also comes of unit testing. The this ascent statements generation represents an existing new era of research in software testing, with the potential to greatly improve the efficiency and accuracy of unit testing in variety of contexts, and they made the necessary standards and quality and accuracy. Okay, these are the this is about the topic. Okay, generating accurate assert statements for unit test cases. Okay, thank you.